Today's problem was submitted by a viewer, and it says, find the square roots of 21 minus 6 root 10. Okay. Well, I'm pretty sure this is a positive number, right? This is only slightly greater than 3, the square root of 10. And so multiplied by 6, we expect it to be slightly greater than 18. So we have x squared is equal to 21 minus 6 root 10, and we want to find what x is. So, I mean, of course, we could just write it as the square root of the whole thing, but I think the point of this question is to write it as the most straightforward, the most simplified expression that's possible. So some things that are coming to mind are maybe it'll be useful to consider, I don't remember what it's called, but like the conjugate term, multiplying by the conjugate term to see what happens. So for example, if I just consider y squared is equal to 21 plus 6 root 10, maybe I multiply these together, and I have xy squared I don't know if this is going to lead to anything, but I'm just messing around here to see what could happen. What is 21 squared? $81. Okay, so x times y is equal to 9. Or negative 9. Yeah, or negative 9. Does this help? Okay, this might lead somewhere. I probably should have started with this. If you know some stuff about expressions of these forms and algebra, let's just see what happens. So what am I doing? I'm kind of specifying that x has to have a form like this. Whether that's true or not is, a long and complicated question. So then, of course, x squared is going to be this. And I want to make this expression equal to that expression. So the square root number here, c, the form of this says that we should probably choose that to be equal to 10. And then once I make that substitution, I'm going to group all the terms that have a root 10 in them. So there's that there. That should be equal to this. And I want what's left over, the part without the square root 10, to be equal to that part there. So I now have two equations. A squared plus 10b squared is equal to 21. And 2ab is equal to negative 6. And of course, I expect there to be multiple solutions to this because I know if I have values of a and b that work, negative a and negative b will also work because it's just a square root. Okay. So I think what I'll do is I'll just take this and substitute for one of the values up in here. Okay, and I can treat this like a quadratic equation. I hope I get a nice expression for alpha. Does this factor? I think this is a correct factorization, but let's just check by reversing the steps. (10 alpha squared minus 21 alpha plus 9). Yeah, looks like it's right. Okay, so this says that alpha is equal to 3 over 2, or alpha is equal to 3 over 5. I'm not sure why I'm getting two very different numbers here. But alpha is equal to b squared. So this says that b is equal to plus or minus root 3 over 2, or b is equal to plus or minus root 3 over 5. I'm hoping that when I substitute the values of a and b, so now that I have b, I have a, I'm hoping that when I substitute those back into here, some kind of cancellations end up giving me the same thing. So I'll start with this value of b, and I'll come back to that value of b later. And we'll also start with the positive square root. Yeah, like I was hoping that a and b would not have square root signs on them. Kind of defeats the purpose of setting things up like what was above. But let's just continue with this. So I said that x is equal to a plus b times root 10. So this is what I get for that first pair of a and b. Of course, if I multiply both of these by -1, that'll correspond to the other root here, but it won't, it'll still, I should still have x squared is equal to this original number, but let's check. So x squared is equal to, sorry, my brain is working a little slow today, so I'm going to write it out like this and see what happens. So x squared is equal to 15 minus 2 times the root of 6 times 15 plus 6. So x squared is equal to 21 minus 2 times, what does this factor as underneath? We have 2 times 3 times 3 times 5. Yeah, x squared is equal to 21 minus 6 root 10. So that works. That is a square root, or the negative of that. And I suspect, I'm pretty sure, that if I proceed with this one, we'll end up getting the same thing, but terms will kind of appear in different places. But I'm going to go through and confirm that this does make sense. So b, I'll choose as being the positive root of 3 over 5, and a is supposed to be equal to -3 over b. Yep. So that is -3 root 5 over 3, which is equal to root 15. Okay, so then x is supposed to be negative root 15 plus root 3 over 5 times the root 10. And you can see when you work this out that this is the same as the previous value of x. In fact, this is the negative of what we had solved for before, right? So this is root 6 minus root 15. And here we have negative root 6 plus root 15. So this will also work, certainly. So those are the two roots. Let me write it out in full. X is equal to 6 root 6 minus root 15, or root 15 minus root 6. Yeah, it's a little strange the way I set this up with the way I set this up by saying that x is going to be of the form a plus b root 10. I expected to be able to solve for values of a and b that were both real numbers, so that so that x would still have a root 10 in it. And that didn't turn out to be the case, right? X has a root 15 and a root 6, but okay, it got us there in the end. I don't think I've ever really done a problem like this before, so that was really cool. I'm happy that my instinct did kind of pay off in the end, although not in exactly the way that I wanted it to, or I expected it to. Yeah, thanks for the submission, and thanks for watching.